These are the frequently asked questions for section 4.5, day 3. Starting with number 46, we have a hot air balloon. And it says a hot air balloon over Albuquerque, New Mexico is being blown due east from point P and traveling at a constant height of 800 feet. And I just took a peek down to see that they've got a nice picture for us there. The angle Y is formed by the ground and the line of vision from P to the balloon. This angle changes as the balloon travels. A says express the horizontal distance x as a function of the angle y. Well, here's our angle y. And this 800 is definitely an opposite side, and the x is adjacent. So opposite and adjacent would give us tangent. The tangent of y equals 800 over x. And what they said was that they want us to have x equals something to deal with y. So to do that, a lot of different ways. First, I guess I just multiply by x and get x out of the denominator. And then divide by the tangent of y. And for purposes of putting this in a calculator, I would absolutely just leave that as it is. Because as you know, we don't have cosecant, secant, and cotangent buttons on our calculator. The book chose to go ahead and say, well, this is the same thing as 800 times 1 over the tangent of y. And it is. So they're not wrong. It's just that as far as actually finding answers by using this, we would not want to see cotangent of y, which is, of course, what you get when you take the reciprocal of tangent, because we just don't have cotangent button on our calculator. I would much rather work with tangent than cotangent. So either one of these, I would stick with that one if I'm going to be using it for something. But if I want a really nice and purdy equation, then we'd probably go with the cotangent. B says when the angle happens to be pi over 2 radians, so they're using the formula that we just developed. It says what is that horizontal distance from P? So what we're trying to figure out is x. And what would x be? And like I said, I would go ahead and just leave it as 800 over the tangent of y. And they're now saying that that's pi over 20. Well, that of course is in radians. So the first thing we have to do when we go to grab the calculator is get ourselves into radians mode, which it always, this one already happens to be in. And then we would go ahead and punch it in. So 800 divided by, and I'm going to use parentheses because again, you really can never use too many parentheses, but you can always use too few, and that'll mess up your answer. So tangent, and we need pi divided by 20. And this way the calculator knows, take that pi, divide it by 20, figure out what the tangent is, and then take 800 and divide it by that. And there we are. And let's see, it says when the angle is pi over 20, what is its horizontal distance from P? So we use 3 decimal places here, but it's going to be, pretty small. It's 1/1000th there. But we would certainly put that x is approximately 5,051.001, and this was all in feet. So there's part B. And then C says an angle of pi over 20 radians is equivalent to how much in degrees? Well, we shouldn't need a calculator for that one. That's conversion. So we've got pi over 20 radians. And again, the label there is radians. So we would want to multiply that times 100 degrees over pi radians so that the pi's will cancel out. And then 20 will go into 189 times. Top times top, bottom times bottom, 9 degrees. And we have it. 52 says, true or false, if x equals a is an asymptote of the secant function, then cotangent of a equals 0 and justify your answer. All right, so let's look at this. X equals a is a vertical asymptote of secant. Okay, secant equals 1 over, so secant is a secondary trig function, and that's what we get when we flip cosine. So they are saying that when we get a asymptote and asymptote out of this. It's because we're dividing by 0. And really, it's because the cosine of A is going to be 0. So they want us to connect that up with the fact that cotangent of A would end up being 0. Well, we would just write. We now see the cosine of A would equal 0 would give us a vertical asymptote. Now let's hook it up with what we know about cotangent. So cotangent of any A equals, well, let's see, tangent is sine over cosines. Cotangent is cosine of A over sine of A. And if it's a vertical asymptote, that means that the cosine of A is 0. And I better keep that with lowercase letter there. If we have a 0 in the numerator, that's perfectly fine. We're going to get 0. So the cotangent of A would be 0. And that means this is true. So it's all about the asymptotes showing us when we have a 0 in the denominator. And then when that gets flipped to figure out what cotangent is, now it's in the numerator. Number 54 says the graph of y equals the secant of x never intersects the graph of y equals what? Scratch off here is our y equals x because that's the perfect diagonal through first and third quadrant. Obviously that's going to hit our secant at some point. X squared, well, you know, that's a possibility, but probably not. I mean, if we think about the numbers we're going to put into x squared, it's definitely going to hit our secant at some point or another because its domain is all real numbers. So, you know, scratch that one off too. They're just using kind of a process of elimination that you could use if you're taking some kind of standardized test. Cosecant, okay, well, we know there's overlap between those two because of the way we establish our asymptotes and the periods for those. So not necessarily that one. D is cosine. Well, cosine is what we get when we flip secant. But if we graph those two together, the cosine graph does go up to 1 and -1, and we know that that's where we graph secant. So our best guess here would be sine of x. And what I'm going to do is go ahead and show you this on the graphing calculator so you can get a visual of this. So let's go in here. And we're going to graph the secant of x, which is really 1 divided by the cosine of x. All right, got that in there. And then we have the sine of x, and we just want to make sure that those are not going to be hitting each other. But of course, I'm going to have to change my window because this is in radian mode, and I want to see what's going on. So my x is here. Let's see, maybe we'll go from -2 pi to +2 pi. And because we do want to see some of that secant, we can't just go to 1 and -1, maybe -5 to 5. Let's see what we get. So pretty obviously, those are our little parabolas there from secant. And there is sine. And you can see they are not going to hit each other. Now maybe you're thinking, wait a minute, it looks like on the x's they're getting closer. Well, then maybe go -3 pi to 3 pi just to verify that they're not going to hit each other. Takes a while, especially with the colored graphing calculators, which are really nice. It's great to be able to see, hey, the blue ones are secant and the red one is our sine graph. But they do take a little bit longer to generate that. Yeah, no matter how far you go out, those two are never going to hit each other. So that is not happening. All right, next one up. 56, the graph of y equals cosecant of x has the same set of asymptotes as the graph of what? All right, cosecant. If it has asymptotes, it's because we have a 0 in the denominator. So cosecant is what you get when you flip sine. Well, that must mean that sine has to come out, sine of x has to come out to be 0. That's when we're going to see this. So I think, okay, what else that we do with the trig functions, our 6 trig functions, 3 primary and 3 secondary, what else would have a sign of 0 in the denominator? And I'm thinking, wait a minute, that's what happens when you have cosine over sine. Okay, tangent is sine over cosine. So this is cotangent of x. So it has to be cotangent of x, which is answer C. So all about breaking it down and seeing if you're talking asymptotes, my zeros are in the denominator. If you're talking about zeros for the graph, your numerator has to be where the 0 comes from.